We're finding the roots of a quadratic equation of this form, ax squared plus bx equals 0. A quadratic equation is one in which the highest power on the variable is a 2. And quadratic equations, when they're graphed, look like a parabola. So here's an example of a quadratic equation that's been graphed. What are the roots of that? Sometimes roots are called zeros or solutions of the equation. In this particular parabola, the roots would be here at -1 and at +3. It just means the places where the parabola crosses the x-axis. In other words, where the y value equals 0. That's where the word zeros comes from. So how do we find the roots if we have an equation of this form? 5x squared minus 30x equals 0. Well, I want to factor that. And so I can look at my left side and say, how could I factor something like this? The first thing I always want to try is, do these two terms have a greatest common factor? As a matter of fact, they do. 5 would go into both 5x squared and 30x. And so I can take out a 5. I also notice that each of these terms has an x, and so I'm going to take out an x as well. When I do that and factor out the 5x from each term, that would leave me with x minus 6 remaining. So that if I were to distribute this 5x to both terms, I'd have the 5x squared minus 30x again. So that's equal to 0. That's what we want. We want the equation to be equal to 0, because now we can use this zero product property, that this quantity times this quantity equals 0. So that means either the 5x has to equal 0 or the x minus 6 has to equal 0. I'll solve each one of those. First, I'll divide both of these sides by 5 to get x alone. So here x would be equal to 0, or in the second case, by adding 6 on both sides, I could have x equal to 6. So 0 and 6 are the two solutions or roots of this particular quadratic equation. Let's look at a second example. This says solve for u. I've got u squared equals -13u. Before I can do any solving or any factoring, I need to move both of these terms to one side of the equation so that this is equal to 0. So I'm going to start by adding the 13u to both sides. That way these terms here on the left will be positive. My leading coefficient will be positive. So now I have u squared plus 13u equals 0. Again, as I look at this and think about factoring, I'm looking for a greatest common factor, and there's no number that goes into both of those besides 1, but I could take out a u from each of these terms, and that would leave me with u plus 13, and that equals 0. So again, using my zero product property, either u or u plus 13 has to equal 0 if their product is 0. So u equals 0 or u plus 13 equals 0. And subtracting the 13 here on both sides, that would mean that u could be -13. So my solution for this quadratic equation would be u equals 0 or u equals -13.